Welcome to the On Maths GCSE Edexcel Higher Tier Paper 2 Extra. This is additional to the Paper 2 we've already released. Enjoy! Hi, I'm Chris Gilpin. Welcome to this extra Paper 2 prediction. Now obviously there are two papers that you've got left to do, the Paper 2 and the Paper 3. So it seems to make sense to you guys who've let me know to do two predictions for Paper 2, since it doesn't matter to the exam boards whether something comes up on Paper 2 or something comes up on Paper 3. Both the papers are exactly the same chances of stuff coming up. Because they're both calculator, it will be very, very similar topics on either paper. So a lot of you have asked me to create another Paper 2 prediction for what I think will be in either Paper 2 or Paper 3. So this is what this video is on. As I've said in my other video, and I'm sure there's a link probably appearing somewhere around me for the other video, the original Paper 2 prediction. All this stuff is available free online on our website, where the numbers change in the questions and you can try it as many times as you want. It's completely free. And if you sign up for free, it will save your scores, so you can see whether you've improved, etc, etc. There's also a lot more on that website, topic busters, demon questions, minute marks. There's a whole range of resources to help you get started. So if there's a topic that doesn't appear on this prediction that you want to practice, if you go into our topic busters or just use our search on onmaths.com, then you can access it. I hope you enjoy the paper, and if you like it, please click like. If you really like it and want to see more from us, please click subscribe. I will release a Paper 3 prediction after Thursday's exam. Thank you. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get one tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get one tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's one done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much one tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out one tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42, because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87, because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft. tissues. Now in your answer, make sure that you write exactly the same as in the question so that it's absolutely clear which one that you think is the best value. Now if you worked the other way, if the question didn't specify how to do it and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Oh, always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. In this question we're asked to draw the line y equals 2x plus 3. Now there's no x squared or x cubed, so I know it's going to be a straight line graph. Now there's multiple ways of doing this. I'm going to do it using a table, and then I'm going to show you a few other tricks of doing it much quicker or checking that you've got it right. The first number I'm going to start with is 0, and this, what I'm circling now, is going to be a coordinate to plot on our graph. So the top number, the 0, is the x, so this is when x equals 0. And what I'm going to do is I'm going to feed that into my equation. So when x equals 0, well, y equals 2 times x, so 2 times 0 plus 3. 2 times 0 is just 0, so y equals 3. Now you don't need to do this working out for every single number, but I'm just doing it to show you how I'm getting to the y. So I'm going to try the next one without any working out. So we've got 1, and so 2 times 1 is 2, plus 3 is 5. Then the next coordinate, we've got x equals 2, so 2 times 2 is 4, plus 3 is 7. And the next one, we've got 3, so 2 times 3 is 6, plus 3 is 9. Okay, and I always go back to the negatives because I can kind of see a pattern with the positive numbers, so I can use that pattern to check that I'm doing this right. So 2 times minus 1, well, positive times a negative is a negative, so that's minus 2, and minus 2 plus 3, well, if I just use the number line, minus 2 plus 3, so 1, 2, 3 will be 1. And I can notice that they're going down in 2, so 9, 7, 5, 3, 1. So let's try the next one. 2 times negative 2 is minus 4 plus 3 is minus 1. Minus 3 times 2 is minus 6 plus 3 is minus 3. So those are my final 2 coordinates. The next step is to plot the coordinates on the graph. So my first coordinate is minus 3, minus 3. My next one's minus 2, minus 1. Then we've got minus 1, 1. then we've got 0, 3, then we've got 1, 5, 2, 7, and 3, 9. Now I want to join those up with a straight line, so let's do that now. And the last step is to label it, and sometimes you're asked to draw more than one line, so we should label it. There we go. Now I can check that this is right because all of the numbers landed on the straight line. If I had one coordinate down here, I'd always check it. You're never going to have a straight line graph that goes up and then dips down, then goes back up again. Okay, so it's an easy way to check that you've got it right. Now I said there was a quicker way of doing this. If you have a look at the graph, the equation, y equals 2x plus 3. This plus 3 tells us where it's going to hit the y-axis, so I can plot that one straight away. This 2 is a gradient, so if I go across 1, it tells us how far up it's going to go, and I just do that a few times to get 3 coordinates, and I can draw my straight line graph from that, and I don't need to put the table. But if the question asks you to fill out the table, obviously you need to fill out the table. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40. 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. For this question, the main thing we need to remember is the triangle. Now the triangle is like the speed, distance, time triangle, but obviously this has nothing to do with speed, distance, time. The formula says that pressure equals force over area. So as long as you've got force on the top, which is measured in newtons, then you're fine, because area and pressure can be the other way around. So if we're asked to find the pressure, so we cover up pressure on the triangle, we cover that up, and it says that it's force divided by area. And it says that the force is 2280 newtons, and the area is 38. So we get our calculator out, 2280 divided by 38, and I get the answer of 60. Now the units, because force is in newtons, and because area is either in meters squared or centimeters squared normally, then the units are newtons per centimetre squared. So it's 60 newtons per centimetre squared. Don't forget, it could be meters squared, newtons per metre squared, and that's absolutely fine for pressure. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. In this question we're asked to find a unit ratio, which just means that we've got one of the parts or one of the sides of the ratio as 1. So we've got to make sure we understand the question. So there's 30 places and 112 people applying, and it's asking for the ratio of places to people applying. Now this is quite lucky, this question, because they're the same way around, but be careful, sometimes they'll ask for the ratio to be the other way around. So if we have places and applying, or applications, so we've got 30 places, ... and there's 112 people applying. Now it says it wants it in the form 1 to something, so we know we need to make this 1. And we do that by dividing both sides by 30. So 30 divided by 30 is 1, then I get my calculator, and 112 divided by 30 is going to be 3.73 recurring. So 3.73 recurring is 3.733333. So if it says it wants it to 1 decimal place, it's a ratio of 1 to 3.7. These questions are just based on a few rules of indices. The first rule says that if you've got 2 powers with the same base, which these two do because they're both A, you add the powers. Now if you think about it, A squared is A times A, a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's 8a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so the next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. When numbers are quite small, it's quite easy just to do trial and error to find the highest common factor and the lowest common multiple. But when the numbers are larger, then the way we do it is with product of prime factors. Now this could come up on a paper which has previously had product of prime factors, and this is distinct enough maybe to come up in its own right. So just because product of prime factors have already appeared, this question has already done that bit for you. So how are we going to do it with these large numbers? And 3,675 and 84 are pretty large numbers. Well, the way we do this is with a Venn diagram. Now I'm going to use the space down here to do this, and what I'm going to do is, because I find it easier, I'm just going to write it not in index form. And then when I do my Venn diagram, I can just cross them out when I've done them. So 2 times 2 times 3 times 7. Okay, so let's construct myself a Venn diagram. Okay. Now, I'm not very good at drawing circles, but I'm going to try my best here. I'm going to try and make the circles as big as possible. So we've got 3,675. I'm just labelling which circle is which, and this is 84. And to do the Venn diagram, we're just going to go through the numbers and write out which ones overlap and which ones don't. So if I have a look at the 84 first, we've got a 2 there. Well, 2 doesn't go into 3,675, so that 2 is going to be on its own there, and this 2 here is going to be on its own. Okay, I think that's it. So the next one, now this 3 appears in both lists, so this 3 goes in the middle. The 5 here only appears in 3,675, and same with this one. And then we've got 1 7 that appears in both lists, but we've got another 7 in the 3,675 list. So that's my completed Venn diagram. Now, to answer question A, to find the highest common factor, all you need to do is multiply the overlapping ones together. So the highest common factor is 21, and that's it. There we are, it's that easy. Now, to find the lowest common multiple, which is question B, what you need to do is times all of them together, every single one. Now you might wonder, well hang on, surely that's just going to give us 3,675 times 84, so why couldn't I just do that? Well, the The overlapping ones we're only going to write once. So the 3 and the 7 in the middle, we're only writing them once. So we would, if we did 3,675 times 84, we would be timesing by 3 and then timesing by 7 again. So we've already done the middle bit. So we've already done the 21 in the middle. And I need to do the ones around the side. So we've got 5 times 5 times 7 times 2 times 2. Now on the non-calculator paper, it might be a bit more generous with the numbers. This one is probably going to be more on the calculator paper, although there are ways that you can do this. For instance, I could pair the 5s and the 2s up, and that would make 10. The 5 and the 2 there would make another 10, so we've got 100. So all we need to do is 21 times 7 and then put 2 zeros on the end of it. 21 times 7 is 147, so put 2 zeros at the end of it. If it's on the calculator paper, you just literally use your calculator to times them out. And so that's 14,700. Well, the chances of us finding that with trial and error are close to impossible, so you can see why this method is so good. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9 times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimeters cubed, because every unit is in centimeters, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1,800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102. and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. This question is all about understanding the notation. What does that mean? Well, what does that mean first of all? That means what is the current term? What's the nth term? That actually is exactly the same as writing nth term. So you always describe terms as u and then a little number depicting on what number you are. So that would be the second term there. So the little n means it's the nth term, and it means the same thing. So how do you get the nth term from the nth minus 1th term? That just means the previous term. So this question's asking, what do you do to the previous term to get the next term? Well, if you're not quite sure what the answer would be, we could just write out that sequence. So the first, second, third and fourth term. Let's do a few terms. So the first term would be 4 times 1, which is 4, plus 9, which is 13. The next term would be 2 times 4, which is 8, plus 9, which is 17. The next one is 3 times 4, which is 12, plus 9, which is 21. And the fourth term, 4 times 4 is 16, plus 9 is going to be 25. So what are we doing to each term to get to the next term? Well, we're adding 4 each time. We know we're adding 4 because the number before the n tells us what it's going up in. So to get the next term, which is the nth term, from the previous term, we just need to add 4. So our answer is un equals un minus 1 plus 4. So cumulative frequency is just a running total. So the first cumulative frequency is just going to be 8 because that's all the frequencies we've got so far. Then I'm going to add on the 4 to the 8 to get 12. Then I'm going to add the 15 onto the 12 to get 27. Then I'm going to add the 22 onto the 27 to get 49. Then I'm going to add the 11 on to get 60. Now, a way of checking this sometimes is that the last one should be the total amount of whatever it is. Well, it tells us there's 60 people in the question, so we should end with 60. Now we need to plot that onto our graph, and we're going to do that. So the first one is, so what have we got? Okay, now the only time you'll look on the left hand side is to see where the graph starts. So we know it's going to start at 0. All the other plots are going to be from the right hand side. Now students get this and frequency polygons mixed up. Frequency polygons are from the midpoints, cumulative frequency are from the maximum points. So we've got 5, 8, so it's going to be 5 across 8 up, which is slightly higher than this. We've got 10, 12, so 10 across and 12 up, just about there. Then we've got 15, 27, so 15 and then 27. Then we've got 20, 49, so 20, 49. And the last one is 25, 60. Now that's not completed yet. What you need to do is draw a curve going through that. Now most exams don't mind you joining them up with straight lines, but on a few of the exams you must use a curve. Now the important thing with the curve is it goes through all the points. So let's try my best here. I'm going to do it in different colours so it shows up. So one continuous curve going through all the points. Now mine's not great, but that's probably good enough to get the full marks. I could probably had it a bit straighter. Back in the old days you used to have bendy rulers as part of your equipment, but you don't have them so much anymore. Okay, so question C, use your graph to find an estimate for the median age. Now the first thing you've got to figure out is what your graph goes up to. Now don't just rely on what the top of this bit is. It's where your graph goes up to. Now mine happens to be the same, but sometimes your graph might go up to 70. The scale might go up to 70, but your actual graph might only go up to 60. And to find the median, you just halve the 60. But 30 is not the median. 30 is how we find the median. To get the median, we need to draw a line across from 30. So we're going to draw a line across until it hits our line. And then we're going to draw a line down from where it hits it. Now mine looks roughly, I would say about maybe 16. I'm going to go for 16 for mine. Now everyone draws the lines a little bit differently, so there's always a little bit of leeway in the mark scheme. What I recommend you do is that you draw the working out onto your cumulative frequency graph so they can see where you got the number from. Okay, last question says, what age were 25% of the people questioned older than? And that's important. Where were 25% of the people older than? Now this is actually asking us what the upper quartile is. So we need to work out the upper quartile, and to do that, easy way of doing the upper quartile is you work out the lower quartile, work out which number you have to go across from, and you do that by halving the number used for the median, so it'd be 15. And then you add the 30 and the 15 together. That's going to be 45. And then we're going to draw a line across from 45, just like we did when we found the median, and down. And I would say that's 16, 17, 18. That's to me about 19. So I would say that 25% of the people were older than 19. Well, let's see if that makes sense. Well, our people were aged between 0 and 25, and so that would kind of just make sense. You just look at the numbers and you go, well, that kind of tallies. Now, this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again. And then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, is this, it equals m. Now m is the amount of things that you marked and then released. So on our example here, we marked 4 times n. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what m is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, well, you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach, which I'm going to use, is I'm going to work out this angle here using the sine rule, and then work out this angle here, taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first. So that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X. So it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine X equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator. And then what I'm going to do is add that to the 110 to work out what this angle here is. And I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that. Then I'm going to type in 180, take away the answer. So that tells me that y is 31.2104 blah blah blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Where's A and B? A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now that's why you must show you're working out, because if you got say 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Now there are 2 things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were 2 things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x, and the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of. What we want to do is factorise it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it, so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency, density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these because I'll need to know what they are. So the first class width, we're at 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10 and the last one's 15. So when I've got the class widths, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2. So can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that would be perfect. So I can go up in ones on the 5 squares. So it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10. So we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1, so it'd be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one, because it's only 1 square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one, and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. This question could be a show that question, where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals, to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that will be 43 over, and half of 900 is 450, half of 90 is 45, so it would be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it. With graphic transformations, anything that happens inside the brackets is going to be affecting the x-coordinates. So what we're doing is we're taking away 2 inside the brackets. Now, when it's inside the brackets, it goes the opposite way around to what you think. You think take away 2, oh, I take away 2 from the x-coordinate. Actually, you add 2 to the x-coordinate. So the new point will be at 0.66 because I've added 2 to the x-coordinate. So a minus moves the graph right and a plus moves the graph left. Just try and remember it's the opposite way around to what you think. Anything outside the bracket will mainly affect the y. So that 2 there for question B will be affecting the y. It will basically stretch it out so that the y coordinate will double. The intercept will actually stay at the same points. So we've got the x coordinate's the same because that hasn't been transformed, but the new y coordinate is going to be 12 instead of 6. This question might just ask you to rationalise the denominator. It might ask this question in the form that it's in, or it might ask you to show that that fraction is the same as another one where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, a positive times a negative is a negative, and any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5, 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimetres and 5 centimetres, and all of them in centimetres, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras, so we're going to square them, add them, and then square root it, and we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places. So the answer I'm going to write is 54.62. The first thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now, at A level, there are much easier ways of doing this, but we at GCSE have to do this using the trapezium rule. Now, the trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between there. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h, actually using the trapezium rule, is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because a and b are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area. So this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. Well, I hope you enjoyed that video and I hope you found it informative. As I said, if you go onto onmaths.com, there's a whole range of stuff for you to do for free. We don't charge for any of our content, so please log in. I'm sure there's probably a link appearing above me. Also, we are releasing a paper 3 prediction after the next exam, so what I'll do is I'll have a look at paper 1 and paper 2 at that point and be able to try and predict the paper 3. Don't forget that this is part of your revision. Don't fully rely on this 100%. Alright, I'm just going to do that, which I'm sure you guys don't do, and from your comments you see this as part of your revision and not the sole focus of your revision. I hope you found it useful. If you like this video, please click like. If you want to see more from us and you want to instantly see when we put up that paper 3 prediction, please click subscribe. Thank you very much.